Aerosols exert a powerful influence on climate. These tiny particles scatter and absorb sunlight and even modify clouds. For instance, aerosols and the clouds they seed together reflect about a quarter of the sun's energy back into space, acting as a planetary sunshade. In general, light-colored aerosols, like sulfates from volcanoes, reflect sunlight and cool the Earth. In contrast, dark aerosols, like black carbon, absorb sunlight and heat the atmosphere, causing warming while also dimming the surface. A dramatic example of aerosol cooling occurred in 1991 when Pinatubo volcano erupted. It blasted sulfates high into the stratosphere, cooling the globe by roughly half a degree Celsius for about 2 years, until it slowly settled out of the atmosphere. They also serve as seeds for cloud droplets, so more aerosols can lead to clouds with many smaller droplets. Overall, human-made aerosol pollution has been masking some of the warming from greenhouse gases. Scientists estimate that if we hadn't added aerosols to the air, the planet might be about 0.4 degrees Celsius hotter than it is today. Of course, that cooling favor comes at a cost: dirty air. And as we clean up pollution, we lose some of that reflective shield. In the long run, cutting greenhouse gas emissions is far more important for climate, but it's ironic that our air pollution has been artificially cooling the climate. Not all aerosols are natural particles. Many are pollutants that seriously impact human health. If you live in a city and see a murky, gray haze in the sky, you're essentially looking at a cloud of tiny particles that you're about to breathe. For example, in October 2010, Beijing was completely obscured by smog, visible even from a satellite. Imagine the health impact. People in the city were inhaling that thick soup of aerosols. Those pollution aerosols go deep into our lungs. The smallest particles can even pass into the bloodstream. Once inside our bodies, they trigger inflammation and can contribute to asthma, bronchitis, heart attacks, strokes, even lung cancer over time. The World Health Organization estimates that outdoor air pollution causes about 4.2 million premature deaths worldwide each year. In other words, millions of people die earlier than they should because of dirty air. Smoggy days lead to increased hospital visits for breathing problems. Chronic exposure to high aerosol levels, like years of living in polluted air, can reduce life expectancy significantly. Clean air policies and technologies are so important. Aerosols also impact our pursuit of clean energy. Consider solar power. It relies on sunlight, and aerosols are like a dusty filter in the sky that dims that sunlight. Haze from pollution or natural dust can significantly reduce the sunlight that reaches solar panels, meaning less electricity generated. In fact, scientists estimate that aerosols diminish the direct solar energy hitting the ground by about 4 watts for every 1 watt they reflect back to space. In heavily polluted regions, this effect is huge. For example, over the most polluted parts of China, aerosol pollution has reduced the potential solar power generation by as much as 30 to 35%, a massive loss of energy. The flip side is a hopeful one. Cleaning up the air can boost solar power, as more sunlight would reach the panels, leading to more efficient renewable energy production. Even high up in the sky, aerosols make their mark. Jet aircraft actually create their own aerosols in the form of contrails, those thin white lines that trail behind airplanes. Contrails are human-made cirrus clouds. They have a real, if short-lived, effect. These icy streaks trap heat in the atmosphere like a thermal blanket. Studies show that contrail cloudiness can cause more warming in a single day than all of aviation's CO2 emissions have caused since the dawn of flight. In other words, the global fleet's contrails are enhancing the greenhouse effect on a day-to-day basis, especially at night when their heat-trapping effect isn't offset by blocking sunlight. Aerosols can also pose direct hazards to aviation. Volcanic eruptions, for example, spew vast amounts of ash into the atmosphere, and these volcanic ash clouds are extremely dangerous for airplanes. The fine, glassy particles in volcanic ash can clog and destroy jet engines mid-flight. That's why during major eruptions, air traffic is often halted. In 2010, an ash plume spread over Europe and forced thousands of flights to be canceled for days. Even large dust storms or wildfire smoke can reduce visibility and reroute flights. Whether it's contrails subtly changing the climate or ash clouds grounding flights for safety, aerosols have a notable influence on aviation. Tiny aerosol particles may be practically invisible, but their impacts on climate, health, energy, and even aviation are enormously important. By using remote sensing technology, scientists can monitor these particles and better understand their behavior. This knowledge is crucial. It helps us improve climate predictions, craft smarter clean air policies, and even optimize renewable energy. In the end, the story of aerosols is a reminder that big effects can come from small things.